Hey everyone, my name is Victor Lundgren. I'm a PhD candidate for the University of Pernambuco in Brazil. But most importantly, I'll be your teacher today. I'll be working with BloomTech to teach you guys about the Fibonacci sequence, what it is, how it works, how we can solve it through Python code. So, the Fibonacci sequence, named after Leonardo Fibonacci, a Italian mathematician, is a problem, is a sequence for a problem he introduces in his book Libera Bacci, where he introduced the following problem. Let's say you have a single pair of rabbits. Uh, you want to know how many pairs of rabbits only through reproduction you have after n months. In his book, he says 1 year. So let's consider that a pair of rabbits gives birth to a new pair of rabbits every month, except on the first month of their lives, where they are still baby bunnies and cannot reproduce. So the sequence goes: you have one baby bunny, it grows, now it can reproduce. Now we have two, it reproduces again. This one grows, now we have three. This reproduces, now we have five. Okay, so notice how he noticed as well that the sequence progresses by adding the two previous values. So 1 and 1, 2, 2 and 1, 3, 3 and 2, 5, 5 and 3. The next one will be 8. Okay, pretty simple. He formulated this into Fibonacci of n is equal to the Fibonacci of n minus 1 plus the Fibonacci of n minus 2. Except if n is 0 or 1, then Fibonacci of n is n. All right. Pretty simple. Okay, how can we translate this to code? How can we solve this through algorithms? The most logical way of thinking about this problem is with recursion, which is a divide and conquer method in which we break the problem into smaller problems. So we have this function Fib, which is the Fibonacci. What we want to do is exactly what the formula says. Check if n is 0 or 1, or if it's higher. If it is 0 or 1, then f of n is equal to n. Else, it is f of n minus 1 plus the Fibonacci of n minus 2. Then, we return the Fibonacci of n. Translated this into code, we have the first, we make sure n is equal or higher to 0. Then we say that f of n is equal to n, the base case, right? If it is higher than n, then the Fibonacci of n will be a recursive call to Fibonacci of n minus 1 plus the Fibonacci of n minus 2. Then we go into the Fibonacci function again and again and again until we don't enter this if once. All right, okay, we solve this with this function. However, recursion can be pretty expensive in higher numbers, this solution as well. So let's try to solve this through iteration. Again, we have the Fibonacci function. We'll try to iterate from 0 to n plus 1 and calculate the f of n and keep the previous values as a temporary variable. And by the end, we simply return our variable f of n. Okay, let's make sure n is equal or higher to 0. Then we set our variables f of n and f of n2, our temporary variable. We'll iterate from 0 to n plus 1, remembering how Python works with range, which goes from 0 to n minus to the n minus 1. So we plus 1 the n, so we get to the final number. Then if I is less than 2, if it is 1 or 0, our temporary will be fn, and fn will be I. So it is 0, 0, then f1 will be 0, 1. All right. If it is higher than 2 or equal to 2, f of n2 will be equal to f of n. So we pass the number down, and f of n will be the sum of the previous f of n with f of n2 before this passing. All right. Both of those occur at the same time. Then we run through this for, and by the end, we'll have our number. Pretty simple, all right. Look at our boy Fibonacci agreeing with us. So now it's your turn. You need to create a Python function that not only calculates the nth number, but also prints the whole Fibonacci sequence from 0 to n. I'm sure you guys can make it. Good luck and see you again next time. Bye.